This is the walkthrough video for the PCTC 2024-2025 round 2, question 11, double vowels. So, this is a question where we're given the length of a word, and given that the word can only contain 4 essentially characters, where one of them is a double character, we want to figure out if you got all of the possible combinations of this word that's this number of letters long, put them in alphabetical order, and picked out the nth one in the order. What is that number? Also, what is that word? So if you had 5 letters, a budget of 5 letters, and you made every word possible using 5 letters, we want to pick the second one when we've listed all of those words in alphabetical order. So this is kind of a question that seems to appear every year in PCTC, and it's very mathematical, or at least it can be mathematical. So you can take a recursive approach, and I'll kind of indicate where that's possible as we go through the solution. The recursive approach doesn't get you full marks, but I think it gets you 7 or 8, or some really high number. Mainly just because it's a bit slow and a bit inefficient for the massive inputs, but it does get you a fair amount of marks. But we're going to take the mathematical approach because it's much cooler, useful to learn and know, and truly understand, and obviously gets you the marks. Okay, so what actually is our approach going to be? So let's just kind of go to a whiteboard here, and let's ensure I'm in the right place. Okay, now up there. Lovely. So say we had a budget of 5. Well, we have the letters AA, B, or C, and I believe that was it. Or D. Okay, or D. So we have 5 characters to fill with these letters, and of course AA counts as 2 characters, but you always have to have 2 A's together, which is what makes this question a tad harder. Okay, so say we wanted, I think we're not going to go with the example because I think 2 is a bit short, and I think also 4 is a bit short. So we're going to go with 6. So say the first input was a 5, and the second number that was inputted was a 6. So those were your 2 inputs, 5 and 6. So how do you figure out what the 6th thing is when this is in alphabetical order? Well, what we're going to do is we're going to build up the string from left to right, for the answer string, the output string, left to right. And we're going to do 1 character, or I guess for the case of AA, 2 characters, or like I guess 1 vowel, or 1 thing, and we're going to call AA a thing, B is a thing, C is a thing, and D is a thing. So we want 1 thing, and we're going to slowly build up our string 1 thing at a time until we hit 5 characters, and we know that it's the 6th one in order. So the first question, how do we choose what the first thing that we put in our string is? So like what goes there? 2, 3, 4, 5. What goes there? So say we decide to put, okay, so I'm going to ignore AA for now because it's a bit bigger. But say we decide to put a B in there. So if we put a B in there, well, we've skipped over all of the A's. We skipped all of the A's. So if you start with a B instead of an AA, so say we had an AA, well, how many are we missing by skipping over the AAs? So we can either start with an A, a B, or C, or a D. If you start with a B, we're missing all of the AAs. How many strings are there, or how many words are there that start with AA? Good question. So we can kind of quickly do this manually. So there's AA, and let's have another AA, B. We can also have C, D down there. And it's going to get a tad long, but we'll only do this once. Alternatively, you could have the B at the start, and then have an AA there, and you could also have a C and a D at the start, of course. And this assumes you want an AA in your final answer. What if we don't want an AA in the final 3 characters? Well, maybe we have a B, 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 or maybe a B, B, C, and so on. And so we kind of split this off into 2 sections. The first section is assuming you want an AA in the remaining 3 characters, because that's much easier. There's only 6 possibilities, which we've listed out here. But if you don't want that, there are loads more possibilities. And how many possibilities are there? Well, we're going to have to use some maths. I believe you learn this in maybe year 8, maybe a bit long later on, I don't know. But you should learn this relatively early on in your maths career. And it's about combinations. So say we can put a B, a C, or a D in one of these 3 spots. And we can choose from essentially which letter we put in each of those spots. So there are 3 choices for what we can put there. We can put a B, C, or D. There are 3 choices for what we put there. There's B, C, or D. There's 3 choices for what we can put there. B, C, or D. Assuming we don't want to use any A's for now. So that leaves us 3 times 3 times 3 possibilities, which is equal to 27. So that's a good thing we didn't work out all of these, because there are going to be 27 of them. So 27 of those, and 6 of these. So in total, there are 33. There are 33 possible cases of this string that start with A/A, because A is coming together. So if we decide to skip straight to a B and instead start the whole thing at a B, then we've just skipped 33 cases. So that would essentially mean that this is the 34th string. It's a 34th string, right? Because there are 33 cases that start with A. So what's the very first case that starts with the B? That's obviously B with a little vase following it. And therefore, this is the 34th case, which we've just skipped 33. Okay? And we're going to kind of use that logic to figure out. So at each position, as we go from left to right, we're going to say what character do we want to put at that position. And we're going to figure out how many total combinations exist should we put that character. And if the total amount of combinations is bigger, so in this case 33 is bigger than our input of 6. Since 33 is bigger than 6, we know that our answer starts with AA. We know our answer starts with AA because say we started with B, right? As we just said, this is the 34th number in the list. And obviously our input was 6 for the order number that we want. And 6 is below 33, like 34. 6 comes before the 34th number. So therefore we don't start with a BB. We have to start with an AA, right? We have to start with this. Now the next question becomes, what goes here? Would we go another AA, another B, B, C, or D, or whatever? But we just apply literally the exact same logic that we just did. But now let's kind of complete this question. So what goes there? So let's assume that we want to put a B there. Well, again, if you put a B, we just skipped all the AAs. So let's first calculate how many possible options there are. How do we put AA? So there's AA. If you put AA, there's AA, B, C, or D. Right? Since there aren't 2 characters left, we can't have another AA because A has to come together in a pair. So it's either B, C, or D. So if you have an AA here, there are 3 options. There are 3 options. Should we put an AA there? Now 3 is less than 6, right? So in our ordering, the very first 3 strings are going to start with 4 A's. And then string 4 is going to be B, AA. Again, basically what we just saw, but now shrunk to a scale of just 3 characters long. So this is going to be the 4th. This is going to be the 4th number in the string in the list. And are we correct? Of course we are. If we go to the example over here, the explanation says, well, the first 3 all start with 4 A's. Then the 4th one is AA, B, AA, which is exactly what we have over here. So just like that, we've calculated, well, we can calculate where everything is. So now the question is, right, so we are now on our 4th, like right now. So this is the 4th iteration. Now the question is, do we put is B actually the correct answer for this specific character, or are we meant to put a C? Like, how do we know? And we know by, again, now we're going to assume it starts with a B. How many options are there? So there's AA, there's B, 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 C, C, B, and so on. And how many of those are there? Well, there's like 3 options times by another 3 options, right? Because you can either choose B, C, or D for each of those. Same logic we had before. That's 9 options here. And obviously 1 option here. So in total, there are 10 options if we start with a B. So there are 10 options if you start with a B, on top of the fact that starting with a B is already the 4th option. So what that means is this is option 5, plus another 9, sorry, no, this is option 4, because that's the very initial B one, plus another 9. So that's actually going to be 13, because, again, if you recall, this was the first 3, therefore the 4th is whatever goes on here. So the first 3 plus another 10 is 13. So there are 13 possible options. Should we start with a B? Now 13 is bigger than 6. Therefore, B is indeed the next character. Because if 13 is bigger than 6, that means there are more options than we actually want or we care about in our list, because we want to stop it when we get to number 6. So yes, B is the next correct number or letter. Okay, now what do we put? So now again we can try color again. We can try AA. And as we just discussed, this is option number 4. Yeah, order number 4 on the list. We don't want 4. We want 6. Okay, so what if we replace that with other possibilities? Well, again, we discussed before, there are 3 times 3 possibilities, so that there are 9 possibilities for what we can put here. Now, since BAA is the 4th, we want the 5th and the 6th. So we want 2 more than the 4th, right? So 2 is the difference we care about. So from what we currently have here, I guess the whole thing. From what we currently have here, we want to move 2 further down the list, or yeah, 2 further down the list. So I guess the next thing to do is kind of what goes here. Well, again, going in order, let's put a B there. So a B, and therefore, well, we can't put an A there because we need another A, so we can't put an A there. But the next thing we can do is a B. Therefore, this option right here is option number 5. Right, we don't want 5, we want option number 6. So let's just get rid of the last B and replace that with a C. Now, why do we know that's what we have to do algorithmically? Well, assuming we had another B here, let's do the same thing. How many numbers, how many letters can go there? And what's the like? There are 3 options, right? B, C, or D, right? So if we start with this, there are 3 options for what we can have. And if you go remember back to this, we were at option 4, right? So at minimum, if we have another B here, we are at option number 5 actually, because we've skipped from the A. So yeah. So for this so far, we have hit 4 options. For this, by choosing a B, we have hit a 5th option. So like the 5th number down the list is what I meant. And therefore, if that's the 5th number down the list, well, if you have another B here, that would be the 5th. If you have a C, that would be the 6th, which is what we want. And if we have a D, that would be the 7th. And we can kind of follow down this process, but obviously we've already hit the answer, which is C. So the actual right answer would be A, B, B, C. Is that correct? I mean, I hope so. So if you look at the first 4 things here, the 4th thing is A, B, A, which is what we said. Therefore, the 5th thing has to be A, B, B. Therefore, the 6th thing has to be A, B, B, C. Like, that's just very easy to do logically yourself, which is manually. And that's what we have here. So you can kind of see, we begin to have a glimpse of some sort of algorithm, some sort of repeatable technique that we can apply to this problem, moving left to right to figure out what the answer string is. And so now the question is, well, how do we write the code for that? So let's dive straight into the code. Right, so the very first things to do are input the first 2 things. So n and m is what the question calls us. We're going to do the same. So n is obviously a number. M is also obviously a number. Now let's have the answer string just called answer or ans. And remember, the goal is always to get to m. So let's and we get to m by building up our answer string until it's complete. When's our answer string complete? It's complete when the len of the answer string is equal to n, which is the input that tells us how long our answer has to be. So whilst this is not true, whilst the length of the answer is not as long as it's meant to be, then we are not done solving the problem. So let's just keep repeating the logic we're about to say. What's the logic we're about to say? So we want to say, so we essentially want to do what we did here, which is try out, let's go to that. Try out each of the 4 options that we have at any given point. We can either add an AA, add a B, add a C, or add a D. So what are the 4 options? Let's just quickly create a list with them. So let's just say options are AA, B, C, and D. As we can see in the question, we are considering an alphabet that only consists of those things. Okay, so there's the options. So we're going to try each option. So let's say for option in options, we want to repeat this for loop and try out each of these 4 options until we figure out which option is correct. The same way over here, we tried out AA and that ended up being correct. We tried out AA again, that was wrong. So we then had to try out B and that ended up being correct. We tried AA again, wrong. Tried out B, correct. Tried out B here, wrong. Tried out C, correct. So we want to try out each of the options at each of the positions as we move from left to right to figure out which option we want at that given position. So for options in options, well, the first check we should do is, well, you can't have an AA right at the end, right? Like you can't put an AA there because there's no space for the AA. So if you're in this current character, this current position, you can't select an AA because there's no space to put the AA, then your length of your answer will be too long according to the input. So let's just do a quick check for that. Let's say if len option plus the length of the answer that we currently have so far, if that is bigger than n, then let's just not consider this option. Let's just continue this option, like continue this outer for loop. We don't want to consider this option. Okay. Let's just make sure that's correct. Yeah, that's correct. Okay, so that basically solves that edge case. So now we are going to assume we're actually going through all the options. What do we want to do? Well, we want to figure out essentially how many of the remaining characters. So say we are currently at option A right at the beginning. So let's say like none of this exists, and we have decided to just try AA because that's what our code does. It tries AA first. Now our question is, how many possibilities are there of these three characters? Just these three characters. How many possibilities are there? And if you remember, I don't actually remember. I think, oh yeah, it was 13. No, it wasn't 13. It was a massive number. It was 33. There are 33 different possibilities of what these three characters could be. And that's the answer we want to answer. That's the question we want to answer. Because if you figure that one out, we then know whether AA is correct or not, right? Because we then know if this is within that band. So, how many characters do we actually have remaining in our budget? Well, we have the length of answer. We have n minus the length of answer. But we also have the length of options to consider. So we should say if n is our goal, and len answer is how many characters we have successfully completed, we also need to now minus off the length of the option, and this will give us essentially 3 in this example. It will give us all of the remaining characters we have left. And what we want to do with this, we essentially want to calculate how many options exist. So let's actually just throw that in a function. So let's say what's this function going to be called? Let's just call it calc. So calc is going to be a function. We're going to throw this number into calc. So let's write the function up here. So let's say def calc. And what are we given? We're given a length, essentially. A length of the amount of characters we want to consider the combinations of. So what is the mathematical expression for essentially what the maths we were doing down here? And as you may be able to tell, and I would encourage you to kind of pause throughout this video and try and figure stuff out yourself. Just spend like 2 or 3 minutes at points throughout the video to pause, figure stuff out yourself, and then come back and see what the answer is. Whether you made progress or not, that doesn't really matter. It's all about thinking yourself so you really understand what we're doing and the problem. As opposed to like no one really cares if you solve it yourself now. It's all about being engaged with this. So what do we do to calculate this? So we can go from essentially assuming, so AA is what causes the issues, right? If it's just BCD, this is trivial. Now the AA causes the issue. So what we can say is we're going to go from assuming there's 0 AAs in our final 3 to now assuming there's 1 AA, and then assuming there's 2 AAs and then 3 AAs and so on. Now in this case, we can only have a maximum of 1 AA. So given essentially a string or a target of let's say length 10, we want to essentially say, okay, first let's calculate how many possible options there are if you have 0 AAs. Perfect. Now let's calculate how many possible options there are if you have 1 AA. What about 2 AAs? What about 3, 4, and 5 AAs? Because that's the maximum you can have if they're a character length of 10. And I think that's the most intuitive way to do it. There are probably other more mathematical ways to do this, but I think that's the most intuitive. And it's one that you can feasibly come up with in PCTC, as opposed to coming up with some crazy maths. This question is pretty hard if you haven't come across similar styles. Okay, so for essentially AA count in the range. So how many AAs are we starting off with? Starting off with 0, and what's the maximum number of AAs we can have? The maximum number is the length, like literally just the length, integer division by 2. That's the maximum we can have. That's the maximum number of AAs we can have, right? Because if the length is 10, well, we can only have 5 AAs because AAs come in pairs. If the length is 9, we can only have 4 AAs because it comes in pairs. So this is the maximum. And of course, because it's Python, we then want to ensure that we add 1 to the range to ensure that we actually hit the maximum because it's non-inclusive. And we don't actually need the 0 here because it just does that by default. So this is for how many AAs exist. Okay. So let's just assume there are 0 AAs. Well, then what? Then we essentially just take the length and we do 3 to the power of length, right? We do 3 to the power of length. Because, as you discussed before, this is just 3 times 3 times 3. 3 options times 3 options times 3 options, because it can be B, C, or D. So there are 3 times 3 times 3, so 27 possible options in this case. And that's again, that should be relatively basic maths for you. So 3 to the power of the length. Now, of course, if there is one AA, for example, well then the length, or the length that we have remaining, the budget that we have remaining for the other 3 characters decreases, right? So it's not actually 3 to the power of length, it's 3 to the power of the remaining length that we have. So let's just kind of change that variable to remaining length. And what is remaining length? Well, remaining length is the total length minus the amount of length that's taken up by the AAs. So for every AA, it takes up 2 length, right? So we take the total length and we minus 2 times the amount of AAs we have, because it comes in pairs. And this is the remaining length that we have for B, C, and D. So this is actually the equation that we want. Okay, so this will seemingly solve our problem, right? Now the question is, what if you have, and let's just kind of quickly draw this. Let's do it over here. So 1, 2, 3, 4. So say the length in this function that we're given, length is 4. Well, you can also have 0 AAs, in which case there's 3 times 3 times 3 times 3, 3 to the power of 4, which is 81 possibilities. There's 81 possibilities with 0 A's. So with 1A, how many possibilities are there? So there's an A and an A there. Well, here there's just 3 times 3 again. So there's 9 possible options. Let's use a different color. There's 3 times 3. So there's 9 possible options. But the AA can also go there. So if the AA goes there, well, there's 3 times 3 possible options for the other 2. So there's 9 plus 9. Well, the AA can also go there, right? Therefore, there's another 3 times 3 possible options. So there's 9 plus 9 plus 9 options in total. So in total, there are actually 27 options if we decide to put one single pair of AAs in it. So the number down here should be 27. Now, what about if you have decided to put 2 AAs? Well, if you put 2 AAs, well, they just go there, right? Like there's only one possible option. So the answer there would be 1. So I guess the question that we're trying to ask is this case. How do we know how many of the 9s, or whatever number it is that we want to add, how do we know how many of them exist? And the question, well, the answer is just look at all the different places AAs can go. And what are all the different places AAs can go? Well, given that we're choosing from a certain length, which we're calling length, how many things are we choosing? We're choosing the number of AAs. So this is kind of just like an n choose R problem. If you haven't come across n choose R, then honestly, you probably haven't covered enough maths for this video to be useful, or for you to be able to solve the question very easily today. So go learn this and then come back in an hour once you know that. So n choose R. And you may kind of not remember it until I maybe use this type of notation. So on your calculator, kind of say something like this, or this probably. I guess in real life, I don't actually know the notation we use. I forgot what it was. I think some people do that. Some people put the n on the other side. I don't really know. Let's just go with the calculator version, because we're doing computing. So n choose R. So from a given length, what are all the different options for putting pairs? So R is pairs. R isn't actually the number of A's, it's the number of pairs of A's. So given the length, how many combinations are there of putting, or how many choices are there of where we can put R pairs of A? And now the next question is, how do we implement n choose R in Python? Well, you don't. You can do the math yourself. It's actually not complicated. You can just kind of Google the n choose R equation, and then implement that pretty easily yourself. But we're just going to use a module from, or command from the math module. So from the math module, we're going to import the comp command, and just check that's what it's called. Yes, we're going to put in the comp command, and the comp command is basically the n choose R command. So it literally just is com. Why are these indents different? Okay, let's fix that too. Okay, so we're choosing com, and the n goes first, which is going to be the length, and then the R goes second, and the R is just going to be the AA count, the number of pairs. of AAs, or the number of AAs, which is the number of pairs of A's. So coming back to earlier, like why do we care about n choose r? Because that tells us how many of these things we actually want. So we take this, which in this case, in this example we had up here was the 9 essentially. We take that and we want to multiply that by the possible places we can put A. So for example, n choose r, say n was 4. Actually that's not going to work, right? Because n is not just the length. Because the problem with that is, in this case, say n was 4 and r was 1. So we're looking at this specific case. Well, so 4 choose 1, I believe is 4. Well, yeah, obviously it's 4. And yet we're not doing 9 times 4, we're doing 9 times 3. Why? We're doing that because each pair of AA takes up 2 characters. So we actually don't do n choose r, where r is the AA count. We have to do n choose r where AA is the sorry, ignore that. So we are doing n choose r, but n is, so r remains the same, but n changes. So n is not the length that we have here. N is the length of what it is if you get rid of the duplicate A. Right, so in this case, if we know there's going to be 1 pair of A's, we can get rid of a duplicate A, and now we're essentially looking at the problem, assuming there are 3 characters. So it's going to be 3, choose 1, which is 3, which is the amount of 9s we had here. So to the length, we actually modify the length to account for the fact that each of the R's, each of the AA counts is a pair, which effectively changes the length, right? Because AA blank is the same thing as AA blank if you just swap around the AAs, right? It's like AA blank is equal to AA blank, obviously. But this current equation doesn't account for that. So let's account for that by saying the length is actually going to be the length minus AA count. It's minus AA count because that's the amount of additional AA count, AAs there are, right? Because each A comes in a pair, so we kind of want to figure out how many pairs there are, which is AA count, and then get rid of that many length characters from the length. So this would be the correct n choose r statement, and we just multiply that n choose r by this, and we can add that to a running answer. So let's just say total is going to be equal to that. I'm going to say total plus equals the thing we just calculated, and then at the end of this for loop, we then just return total. So it calculates a total for, again, going back to the higher level, it calculates a total for each of these for loops, for each run of the for loop, and then each run of the for loop basically says, I want this many pairs of A, I want this many pairs of AA, I want this many pairs of AA. And it does that and calculates the amount of combinations we have. So the math is a bit confusing, and as you could tell, I got a bit confused here by forgetting this bit. But it also isn't that difficult, right? I think if you're on sixth form, you could definitely, I don't know if sixth forms are even allowed. I mean, if you're on like year 10 or 11, you've definitely covered this maths, and so you can definitely figure this out. If you're on year 9, you probably won't. If you're year 10, especially year 11, you can definitely figure this out. It will obviously need practice and some like idea of what's going on, but the maths itself, you can figure that out. So that's our function. That's the calc function. Awesome. So that's calc done there. And why do we care about that? We want to see how many options exist. So if, and let's say there's 2 combinations. So we would basically want to say, if combinations is bigger than m, remember m represents the mth thing that we want in a ordered alphabetical list. So if combinations is bigger than m, then we know that the option that we have chosen up here on line 19 is the correct option, right? Because it will contain the mth thing, as we discussed earlier, right at the beginning. So therefore, answer, which is a final answer string, we can add the option to that. And since at this point we've kind of figured out what goes in this character space, we can break. We figured out what goes here, so we can break out of it. And I believe that's pretty much all we have to do for this case. And it should be if combinations is bigger than or equal to m, and it should be that because AA, there are 33 options starting with AA. What if you want the 33rd option? Well, that also starts with AA because I have 33 options starting with AA, so it has to be bigger than or equal to. Awesome. So if that isn't the case, then obviously it's smaller than m. If it's smaller than m, this is where it gets tough because that means we definitely want to check the next option. It means that AA is too small. too high up in the list. So we want to go down to B. So what do we do then? So we don't actually do very much, but what we do have to ensure we do is change M, because M at any given point represents, given the answer that we currently already have, or the things that we've already figured out, given that subset of the list of things that we've already figured out, where does my answer lie? So initially it's 6th, but you can imagine if you have like a B here, or when you had a B earlier, do you remember where I said the difference was now 2? We want to go 2 further from our current checkpoint. Very similar thing. So we actually want to change M by decreasing it by combinations, right? Because we're decreasing it by the amount of combinations we've skipped. Say we want the 37th thing in this list, or this ordering. Well, we're obviously going to skip AA because that has 33. And so therefore we've skipped 33 options. So assuming we have skipped 33 options, which we do, then we want 37th. So that's the sort of 4, 35, 36, 37. That's the fourth string in our brand new set of orderings, given that we now just skipped 33. So we always kind of have to dynamically adjust for whatever our M value is. Because whenever we skip a set of options, we have to decrease M by that number of options because we're skipping them. Okay, and I believe that is pretty much all we need to do. So I believe the answer will just be like print answer. And I think that should work. Hopefully. It's a pretty tough question, so I don't know if I got that. Yeah, nice. And if you're interested about the recursive solution, the reason I actually put this in a function is because you can kind of recode this such that it's a recursive solution. If you want, I think that'd be a fun exercise. Even if you can do this one, I think it'd be fun to practice recursion with that. But yeah, this was the question. It's not even that long. It's 30 lines of code. Like the maths of it wasn't actually difficult. It was more the logic and figuring out this bit. But once you've done one of these questions, and it will take like literally hours for you to internalize what the question actually is, what this answer is. So once you've internalized what this answer is, if you ever see a somewhat comparable type of question, which we see every year, in fact, let's find one right now, then you'll be able to solve it much faster. So let's just go to last year's round 2. So it's not that one, not that one, not that one. Okay, this is improving my point because it doesn't exist last year. Okay, so let's go to the previous round 2. This one. Okay, yeah, I think, no, not that one. Caves, yeah. So caves is basically this problem, right? Because you want to sort these things alphabetically, and then pick the nth option. So I mean, this thing has appeared at least 2 other times in PCTC. I know that, and it'll probably continue appearing in this competition and other competitions. So you kind of get used to this idea of using maths to solve the problem, because if you decide to just generate like this whole list, you're like that's not going to work because it's way too big. Because if you look at this, n will satisfy up to 50, and m will, and the that's useless for us. The actual important value is m will satisfy up to 10 to 26. So if m is 10 to 26, that's a massive number. So you're telling me that we want 10 to 26 strings in our list, and we're going to generate the entire list, and then we're going to select the 10 to 26 string. That's just dumb. And it's dumb because it just won't work, right? We only have 10 megabytes of memory, which is already a lot, and we have to run in under a second, which again, 1 second is quite a lot of time. Despite them being this generous, we still won't be able to solve this just by brute forcing every possible character, or every possible string. Therefore, we have to strategically build up the answer string that we want. And this is the maths that does it. So hopefully that didn't fry your brain too much. Hopefully you learned something. Hopefully you had fun and experimented, or will continue to experiment with the question.